Today, we are tackling a security threat that's probably keeping a few CISOs up at night. And it's not your typical data breach. No, we're talking about how your most innovative AI models could, well, secretly become your biggest security headaches.
So just let this sink in for a second. It's a security leader's worst nightmare, right? Your firewalls are solid, your databases are completely locked down, but somehow sensitive customer data is still getting out. So what's the culprit? It's your own AI model, the very one you built to drive the business forward.
Okay, so what's happening here? The attack is called model inversion. And honestly, this sketch artist analogy is the absolute best way to think about it. The attacker doesn't need to see your data. They don't have to. Instead, they just treat your AI model like a witness, and they start interviewing it with thousands of really specific, crafty questions. By analyzing the model's answers, especially its confidence scores, they can slowly but surely start to sketch a picture of the private data it was trained on. So here's our game plan for this explainer. First, we'll hit the business risk, why this really matters. Then we'll nail down exactly what this attack is. After that, we'll walk through how you can assess your own vulnerability. Then we get to the good stuff, concrete detection methods, a solid defense strategy, and we'll wrap it all up with some practical next steps you can take right back to your team.
First things first, let's talk about why this should be on your radar from a business perspective. Look, this isn't just some interesting technical puzzle. We're talking about your AI becoming an accidental and probably unmonitored backdoor to your most sensitive information.
The impact here is severe, and it hits you from all sides. You've got major privacy violations, attackers literally reconstructing recognizable faces or confidential medical records. That, of course, puts you right in the crosshairs of regulators. Think GDPR, HIPAA, and all the fines that come with them. Then there's the reputation damage. You just do not want to see that AI leaked our data headline. And beyond all that, if your model was trained on proprietary business info, this becomes a new way for competitors to spy on you.
And this quote right here, this is the regulatory trap. From a compliance point of view, it just doesn't matter how the data got out. A leak is a leak. The fact that an attacker pieced it together from your public-facing AI, that's enough to be considered a full-on data breach, with all the notifications and penalties that go along with it.
Now that we get the business risk, let's get a little more specific. It is absolutely critical we're all on the same page about what this attack actually is. Because if you misunderstand the goal of the attack, you're going to build the wrong defenses. The point here isn't to steal your algorithm, it's to steal the secrets that are hidden inside of it. All right, let's clear up a really common point of confusion. Model inversion versus model extraction. They sound similar, but they're totally different. Model extraction is all about stealing the AI model itself. It's intellectual property theft. Model inversion, what we're talking about today, is a privacy breach. The attacker wants to steal your customer's data from your AI. So the vulnerability isn't a weak firewall, it's the fact that your model has essentially memorized way too much specific detail from its training data. So the obvious next question is, okay, how vulnerable are we really? And that's the right question to ask, because this threat doesn't hit every AI system the same way. You need a structured way to figure out your specific risk profile.
This classification table is a fantastic place to start that conversation with your teams. You really need to map every single one of your models to a framework like this. Because if you're at level 4, training your models on things like faces, medical records, or financial data, your risk is critical. You need to be taking action right now. Even down at level 2, with what you think is safe pseudonymized data, you still have to be actively evaluating your controls.
And this is a huge point that trips up so many organizations. You just cannot assume that because you've stripped out names or IDs from your training data, you're in the clear. A powerful model can still learn and leak patterns that allow for re-identification. Anonymization is a good first step, for sure, but it is not a complete defense on its own.
All right, so we've sized up the risk. Now, how do we actually detect an attack while it's happening? Well, it's all about looking for the attacker's footprints in your query logs. You'll find they behave very, very differently from a normal user.
Your security team needs to have these 4 telltale signs on their dashboard. First, look for systematic query patterns. Think structured, machine-like inputs, not natural human language. Second, a strange focus on edge cases, where they're constantly probing the weird boundaries of what your model knows. Third is something called confidence score harvesting. That's when they bombard the model with almost identical questions just to analyze the tiny shifts in how sure the model is about its answers. And fourth, the most obvious one, just a crazy high volume of queries from a single user or IP address.
And here's a great early warning signal for your SOC team.
Before an attacker launches a full expensive inversion attack, they'll often run a smaller test called a membership inference attack. All they're trying to do is confirm if one specific person's data is even in your training set. If you can spot these smaller probes, you've got a really valuable heads up that a much larger attack is probably right around the corner.
So, we know how to spot these attacks. Now, let's talk about defense. And I'll tell you right now, there is no silver bullet. Effective protection requires a real defense-in-depth approach, with multiple layers all working together.
This table really lays out the whole strategy. And the key column I want you to look at is utility cost. This shows that AI security isn't just a technical decision, it's a business trade-off. Simple access controls, that's an easy win. But as you move to stronger defenses like output perturbation, which adds a little bit of noise to the model's answers, or differential privacy, which is a much more advanced technique, you get huge privacy gains. But it might come with a 5 to 15% hit to your model's accuracy. Deciding where you land on that spectrum, that's a strategic business conversation.
Look, if you take only one single action after this explainer, please make it this one. Go back to your teams and find every single model API that returns raw, high-precision confidence scores. For any model trained on sensitive data, that endpoint is a gaping vulnerability. You need to rate limit it, restrict it, or round the outputs. It is by far the single most impactful quick win you can possibly implement.
Woo! We've covered a ton of ground, from the business risks all the way to a multi-layered defense. So let's boil it all down into the essential takeaways you can use to start making changes tomorrow.
So here are the crucial points to remember. 1. Model inversion steals data from your model's answers, not its database. 2. If you use faces, health records, or financial data, you are a high-risk target, period. 3. You absolutely have to monitor your query logs for those probing patterns. 4. A 4-layer defense is really the only resilient strategy. And finally, number 5, never ever forget that regulators see this as a data breach. The risk of fines is very, very real.
And I'll just leave you with this final thought to take back with you. Your AI model has learned the most sensitive secrets about your customers and your business. The question you need to go back and ask your teams is simple. Who else is asking it questions?